While the previous videos were on actually using functions in the C programming language, this one is going to be about writing our own functions. And we're going to use it as an excuse to introduce all the vocabulary and emphasize the difference and the similarities between function in the C programming language and methods, for example, in Java, if you studied Java before to come to this class, or functions in Python. Okay, so it's going to be one of those catch up, get up to speed on how to use and apply what you already learned into a new programming language. So let's jump into the code. We are going to do something very complicated. We are going to do, again, a hello world, okay? And we do that so that we don't have to worry about the complexity of the application we're trying to develop, okay? It's trivial. But everything that I'm going to tell you about, because the application that we're trying to write is trivial, is going to be about actually the syntax, about the terminology, about the things that we want you to learn, okay? So we take something that is totally trivial here, hello world, and we are going to make sure that it compiles, because when you say something is trivial and it doesn't compile, this is always a bad thing. And then we're going to run it, and it works just fine, okay? So we're good. All right, so now let's transform that hello world. Let's say that for whatever reason, I want a function called DisplayGreeting, okay? Because I'm going to do a lot of hello words all over my app. So I need this code here, the printf hello world, and everything that's going to go along with displaying greetings, I need it to be removed from the main and put into a function named DisplayGreetings, so that if I want, I can call it from wherever I want in the code as many times as I want, and I don't have to rewrite the code for printf hello world. So how do I define a function? So defining a function means you tell me its name, display greetings, and this is very, very similar to what you have been already doing in other programming language, okay? Give me its name, tell me what it's going to return. So the keyword that we use in C, just like in Java, to mean that a function doesn't return any value, it's void. So void display greetings. In between parentheses here, we would have the list of parameters that the function accepts. Here, when we call it, we don't have to give it any data, so we don't have any parameters for that function. And then a pair of curly braces that define a block, and inside that block is a code that has to be executed, okay? And if I wanted, I could have local variable here, age equal 42, and I could have local variable here that I use inside the method. And the principle of scope of variable means that any parameter that I have here, any local variable that I have inside this function, is isolated from any variable that will be defined inside the main. The C programming language uses the curly braces, the notion of block of code, as a unit for scope. Okay, so for example, here I declare age right here. So from the line where it's declared to the end of the currently encapsulating scope, which is that pair of curly brace, okay, the block of code, I can use the age variable. But if I'm here in the main and I try to do age equals 0, for example, it's not going to find it. I'm going to show you the compilation error that it does right away. So for now, let's finish here. For example, I want to display you are %d years old. And I'm going to insert the age here. Okay. All right. Hello world, you are %d years old. Control S doesn't make sense, but that's okay. Let's go and compile so I can show you what the compiler says exactly when we try to use those variables. So it's going to tell me it's undeclared, but it was declared here. Oh yeah, but different scope. Okay, I declared this variable inside this block of code, so it's only usable there. Here I'm trying to use it across functions, from the main function where it's actually existing, the display greetings function, not going to happen. Okay, so think of all of your functions as isolated programs, and the only way to communicate between the main function and the display greetings function is to send data or receive data from the function. We're going to talk about that in a second. Okay, but right now, let's try to make sure that this works in its basic form. So I'm go back here, GCC again, a dot out. Hello world, you are 42 years old. Hello world, you are 42 years old. And it would be better if I had like some \n here and here. I think that would make it a little bit more palatable, readable. All right, there you go. So we did our job, okay? We did the job that every function in any programming language does, which is encapsulating some code, okay, so that I may call it as many times as I want from wherever I want, and it's going to execute this code here every time, okay? All right, so next on the to-do list of things that we need to talk about. So we saw about calling function, we saw about defining our display greetings function. So what I'm going to call defining a function is going to be this, okay? Giving everything about the function, the name, the list of parameters, if any, the return data type, if any, here it's void, and the code as well, okay? All of that is going is going to define my function to consist in the definition of the function. Okay, I was a little sneaky. I put my definition right here before the main, which is cool because that means that since the compiler reads the file, you know, top to bottom, it knew already about the display greetings function before it actually encounters the first spot in the code where I actually call that function. So having your definition before any call to that function, yes, that works very well. Okay, that works very well for two reasons. One is when I read this, even just this part, okay, I know everything already that allows me to check that you are using the function correctly. Are you, for example, putting any parameters here? If you are, then you're not using it correctly because this function here tells me that it doesn't take any parameter. The list is empty here between the parentheses. Are you trying to assign the return value of this function to a variable of type int? Well, if you are, then you're doing it wrong because this function is defined as returning void, right? So even just by looking at the first line, what we call sometimes the signature of the function or the header of the function, the compiler can tell already whenever you are using the function if you're using it right or wrong, okay? So that allows us to compile the whole file. And then once the file is compiled, I need to be able, when I execute my program, whenever I call display greetings, I need to be able to jump to the actual code for that function. Where is that code? Well, okay, you already gave it to me. It was in the definition of the function as well, okay? So compiler is happy, runtime is happy, everybody is happy. Let's move on to making everybody unhappy now. I'm going to take this and I'm going to move it to the end of the file. So I still have my definition technically. Okay, I have my definition, but what I'm trying to show you is that the order in which you write functions definition and the calls to them matters. For example, here, the C compiler again goes top to bottom reading your file. And the first thing that it encounters is somebody is calling a method, a function, sorry, that's called display greetings. And I've never seen it before. So this is that part of the error message, that warning. Implicit declaration of function display greeting. So every time you get implicit declaration, whether it's for a function or whether it's for a variable, you know what that means. That means that the declaration for it was not seen before. So here, implicit declaration of function display greetings, that means I never heard of a display greetings function. Never. So I'm going to assume that you are giving me here what is called a prototype, which is the minimum amount of information to declare it. So defining means giving all the information about your function. That's what we did here, okay? Just giving the name of a function with empty parentheses here because it takes nothing and semicolon. This is seen by the compiler as a prototype. It's not a call. I mean, it's supposed to be a call. We meant for it to be a call to the function, but because it never saw the function before, it's going to assume, well, you are trying to tell me something about the function here. It's totally wrong. It's totally a messed up situation, right? So when the C compiler encounters a function like that, and we have this implicit declaration missing, you know, issue, it's going to assume that the function returns an int. And so it's going to keep going and assuming that this is going to be the same thing. And then when it encounters finally on line 15, when it encounters the definition here of display greetings, it's going to say conflicting types for display greetings, meaning you already add what I consider to be an implicit declaration of display greeting on line 8. And it said is a function takes no parameter and return an int. That's the default assumption, okay, by the C compiler. And now you tell me it takes no parameter, so I could live with that, but it returns void, and there is a conflict, okay? So this is a huge mess. I mean, this is a total misunderstanding between us and the compiler. So the way to solve that, we saw that already, right? Take this, put it up there, and now the compiler is going to read this top to bottom, encounters a definition of display greeting. So now it knows everything it needs to know to be able to validate any call to the function, compile it, right? It knows the name, that it takes no parameter, that it returns void. When it finds here a call to the function, it's not going to be fooled into thinking that you are making an implicit declaration. It's going to say, no, 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 you're calling the function display greetings. Let me check. You call it without parameters. Good, check. You don't expect any return value, check as well, we're good. Okay, this is a good call to the function display greetings. Same thing, check this one, end up, compile the whole thing, generate the executable, and now we're ready to run. Okay, but what if we don't want to always put our definition before any call to the method? Okay, what if for whatever reason I want this definition to be in a different file, maybe, or I want it to be at the end of my file? Okay, how can I get the compiler to still do its job? Well, let me introduce the concept of function prototype. So if I just provide this information, void display greetings semicolon, right? This is only the signature of the function, the header of the function. It's called the function prototype when you put semicolon after it like this. It's a statement that says somewhere else in all the files that constitute your application, somewhere else, or even in a library, there is code for a method display greeting. And that method display greetings, that function display greetings, sorry, is going to take no parameter and is going to return void. This is what I said here. Now that I have said this, it's called the declaration of the function, right? I don't give you the code, it's not the full definition of the function. I just give you the essential information about it so that the compiler may now, when it encounters a call to that function, not fall for the trap again of thinking this is an implicit declaration because I see it for the first time. No, now it heard already about the function display greeting, so it's going to double check. Are you calling it without parameter? Check. Are you not expecting any return value? Check. Okay, this is a good call to display greetings. And then check this one as well, and then move on. And then at the end, it's going to find, oh, this is where the code for display greetings is. So this is the full definition that tells me again the same information that the prototype holds. Okay, so I can match the two together. And then it gives me a block of code that's going to be actually the definition, the code to execute when you call this method, this function. All right. Okay. So that's it for function prototypes. The one thing that I would add here at this point is you remember those pound include stdlib, stdio, stdbool, pound include time.h. We used that in the previous video. We were trying to use the function time, and we realized that we had to pound include time.h to be able to use it. Well, as a matter of fact, those header files, those .h files, they contain generally, that's not the only thing they contain, but they contain generally a healthy amount of functions declarations, okay? So they are full of statements like this one. And they are meant to be included at the beginning of your C files when you intend on using the functions that they declare. So pretty much what I did here is what one of those header files does for me for all the functions that are made available by stdlib, stdio, stdbool, and as we've seen in previous video, time.h, and so on and so forth. Okay, so those header files contain generally a lot of function declaration, that allow me to then write calls to the function. The compiler in turn is going to learn about those functions when it reads the function declaration here in the header file, or when I type them here at the beginning of my file. And when it encounters the code, it's going to validate it. And then later on, so at some point, of course, we need to have a definition somewhere also included in the set of source file that we compile, so that the code can actually do what is called linking all the pieces of the program together and be able to call that function and execute actually its code, find the code to execute. Okay? All right. What else? So we have a function prototype. We have played moving it in front and before and after the main. So now you see how the prototype needs to be always before any call. Let's add some stuff to this function. Okay, so right now we have a function that takes no parameters and returns nothing. Let's add something to it. So for example, I want display greetings to be able to I don't know, to take a name. Okay, so we're not going to do hello world, we are going to do hello and whatever name is here. So when you call a function, we're going to agree on some vocabulary here. When you call a function, what you pass between the parentheses are a list of expressions. Those expressions are going to be evaluated into values, each of them. So there's generally a list of expressions separated by comma, for example, John, and then I'm going to pass the age here, 42, okay? So you can have as many as you want. The idea being that every one of them is going to be an expression, potentially, that's going to yield a value, and that value is actually what is given to the method to do its job, okay? That's calling passing by value, and it's a one-way street, okay? The main is computing some things here and here and sending the result pretty much to the display greeting function. On its side, the display greetings function needs to tell me what it's accepting. So for example, it's going to accept a char star. So char star is the name of the data type for string in C. Okay, so a char star, we're going to call it name, comma. So I'm declaring what is called parameter here. Some textbooks are going to call those formal parameters. Okay, we're just going to refer to them as parameters. Char star name, and then int how old. Okay, so I declare two parameters, and when I call the function, the whole deal is evaluate this. It gives you 44, and assign 44 to the parameter here named how old. So that then the code of your function can use the value, the variable how old, the parameter how old, can use it to display, for example, the age of the person that you're trying to greet. How old. There we go. Okay, and same thing for the name. Instead of saying hello world, I can say hello person S and put the name here. So it's a one-way street communicating. Okay, these are arguments also referred to as effective parameter, actual parameters. Again, there are a lot of synonyms, but we are going to stick to what you give to the function, the value you give to the function when you call it as an argument, and the variable in which you receive the argument, the corresponding argument, are called parameters. Okay, so now we have a little display greeting function that's a little bit more maybe useful. I don't know. It's kind of funny to say useful about a function like that, but you know what I mean. It actually can greet more than just hello world. It can greet anybody of any age, and I can call it here by saying hello John, hello Jane, and I'm going to say 42 as well for the age. But Jane is not cheating. She's not making herself look older, apparently. All right, so save this. Let's try to compile here. It's going to be interesting. You're going to see what the compiler is going to tell us. The compiler is going to tell us nothing, but that's one thing with C programming, right? Sometimes the compiler should catch things that it doesn't, or it assumes that we know what we're doing, which is even worse. So what we have here is we have display greeting, which is a declaration of the function display greeting. And we have here the definition of display greeting. They need to match. Okay, they need to match, otherwise that can cause some problems. So here in display greetings, I need to say that my first parameter is going to be a char star, and the second an int. And that's the minimum I need to specify. Because remember, the prototype of a function is only there to allow the compiler to say, okay, I know what you mean by display greetings. When I encounter you calling the function display greetings, I'm going to actually check that the first argument is of type char star string, that the second argument boils down to a value of type int, that there are only two arguments in that order, and then I say check, this is a good call to display greeting. Okay, so to do that check, you just need the number of parameters that the function accepts, as well as their data type. But most of the time, I mean, I like to do that. I like to put in the prototype also the name of the parameter, just so that when I read the prototype, so this has nothing to do with the compiler, it's just as a human being, when I read the prototype of a function, I know kind of what each of the parameter means. Okay, that doesn't replace having actually a little bit of documentation, a comment or two that tells you what each parameter is supposed to do, but at the very least, when I see name and how old, I have an idea of what you're wanting to do with those things, inside display greetings. So it's optional, but I would say it's a good practice. Save this, go back. Compiler is going to compile it, of course, a.out. And now I have this personalized greeting function that I can use as many times as I want from wherever in my code. So that's one-way communication. Okay, one-way communication is I send data pretty much to the function when I call it. Okay, I send argument that are stored inside the parameters and so on and so forth. What about the other way around? Well, a function doesn't have to return void. Void means it returns nothing. But I could say, for example, I want a function int get user age, okay? And that function is going to be, so I declared it here, this is its prototype, okay? And I'm going to define it down here. There we go, here's the code for get user age. It's going to ask the user enter your age, and then int age, initialize it to 0 because why not, scanf, %d, ampersand age, so we use that ampersand sign as a recipe every time we do scanf, okay? Scanf %d ampersand age, and then we are going to do what with that? We are going to return it. So the return keyword works just like the return keyword worked in the previous language that you studied, okay? It causes me to exit this, this function and return a value that is going to be of the data type. So this expression here needs to match the data type that is declared here and that is declared here. And then inside the main, I can do things such as, int John age equal, and then I'm going to call get user age. Okay? And then that means that John's age here is going to be, well, John age. So I have a function that actually is going to do some work, interact with the user, read a value, and then return it to me, and I'm going to store that here in the local variable John age, and then I'm going to use it in my main. Okay? All right, let's give it a spin. GCC a.out, enter your age. So this time I'm going to change the value, 23. So hello John, you are 25 years old? Well, yes, because it's 23 plus 2. Hello John, you are 42 years old. And of course you can do both, okay? Like for example, I could have a function here that's going to allow me to specify that I'm talking about John here. And then I could do the same for Jane. There we go. Jane age and John age are my two variables. I'm going to use Jane age here, okay? And so that means that my function needs to also accept a parameter, okay? And that parameter is going to be of data type char star. So again, just to show you that it works, okay? I'm not going to put the name of the parameter here, but again, I really like to put the names of the parameter in my prototypes. But just to show you that this is actually not required by the compiler, I'm just putting char star here, And in the definition, I'm going to say, okay, it's a char star, and I'm going to call it name, okay? And enter person S, and I'm asking for the name for that specific person, okay? All right, let's go here, compile this, leave that out. Enter John's age. So what did we use at the beginning? 42. Enter John's age. I'm going to use a different one. There we go. It's working. So now we have covered pretty much we have covered returning values from functions, covered passing values to function, and only passing by values. Okay. Later on, we are going to talk when we introduce pointers. We are going to learn how to pass data as an argument to a function and make it so that if the function modifies this data inside of its code, it's going to have an impact on the main method or whoever the caller is. So I could have a data structure in the main, okay, an array or something like that contains data. I pass this by what we call reference, and that allows the function to modify what's inside the data structure in a manner that's going to reflect also in the caller method. Okay, right now, nothing reflects at all, and the best way I can show you that is if we have a little function, for example, void swap, and I'm going to say it as a int x, a int y, okay, and then I try to do int tmp equal x equal y equal tmp, okay. So this is swapping the content of the parameter x and y, okay. X is saved in tmp, then x is overwritten by y. So at this point, x and y contains the value of y, and then y equal tmp. There we go. We put the value that we saved from x inside of y. So we swapped the content of parameter x and y. Okay. Well, this is all well and funny, but inside the main, if I have a variable int a equal 23 and b equal 42, also type int, okay? If I try to call swap a and b, and I try to display before printf a is %d and b is %d, a, b, okay? If I try to display before calling the swap and after calling the swap the values of a and b, you are going to see that those values do not actually change, okay? And let me comment this out, and we're going to come back onto that when we explain the stack and stuff like that. But right now, I just want to give you like a kind of an intuitive understanding of what's going on here. So implicit declaration of swap, yes, I forgot to do the prototype, didn't I? So void swap, again, int. I don't need to provide the name if I don't want to, but again, this is a good idea to do so. Let's go back and compile. All right, let's run it. So A is 23, B is 42. Okay, fine. And then I call swap AB. So the mistake that I'm trying to draw your attention to, the misunderstanding that is very common when you first learn that kind of stuff, is to think I am passing the variable A and variable B to the swap function. I am passing the variable A and the variable B to the swap. So that would mean that when I get X and Y here, in your mind, you are connecting X to A and Y to B. But this is not how passing by value parameter works, okay? In the C programming language, I told you, these are like just expressions. The expressions are evaluated. So the value of A 23 replaces actually this first argument. So it's like if I was passing 23 directly here, okay? And for B, the value is 42, so I'm passing the value 42 as second argument, okay? That's what's actually happening. That's called passing parameters by value. And so 23 is assigned to X, 42 is assigned to Y. Because of the rule of scope, you know, X and Y are variables that are actually existing only inside the code of this method. So they have nothing to do with A and B. I modify X and Y, sure, why not? And then when I come back to the main, A and B have been left untouched, okay? So this is very important. We're going to cover that again, and I'm going to explain to you exactly why this is working this way as soon as we kind of lift the hood and take a peek under the hood at how our actually calling method works in the C programming language, which is going to be in one of our upcoming videos. But I wanted to kind of seed the idea already in your mind, give you a heads up on what's happening here. We have a way to send data to the method, as many parameters as we want, as many arguments as we want. We have a way to get one value out of the function. And this can be a difference for those of you who learned Python before. In Python, a function can return a bunch of values separated by comma. In C, only one, okay? And you have to declare the type of that value here. So void if you don't want to return anything, or for example, int or double or float or whatever data type, depending on what is the data type of the value you want to return, right? And we've seen how to declare the function, define the function, what is the prototype, this is the declaration part. I've mentioned that the declaration often goes into the header file. We are going to, again, deal a little bit more with header files in an upcoming video. So that's going to wrap it up for our overview of function. I hope that it makes sense and that it connects well with what you learned in the previous course, okay? As usual, if you have questions, Piazza forums, whatever we're using this semester, and don't hesitate to drop by as well into office hours. Thank you for your attention.